The next transformation that we're going to look at the sine and cosine curves are the reflections across the x-axis, and we're going to look at changing the negative in front. So these are still going to involve a vertical stretch or shrink, but they were also going to do a reflection. So anytime we put a negative in front, and this goes back to that base idea that we had when y equaled f at x, when we put a negative in front of it, negative f at x, then this negative, what it does, it reflects your graph over the x-axis. So all we're going to do is we're going to reflect the graph the x-axis, and we can also put positive values in there, so negative a times f at x, and then it'll stretch and reflect. So that's the next thing, relatively simple adjustment to make. What we're going to do is we do the same thing we did in the last problems. We're going to look at the amplitude and see what that value is, and then we're going to graph both of these on the same coordinate axes. So trying to get this to the right size here so we can see everything. So we can see by our equation that the amplitude is it looks like it's a negative 1/5, but the amplitude is really always the absolute value of that leading coefficient. So the amplitude is going to be the absolute value of a negative 1/5, so our amplitude is said to be just 1/5. So in this, our amplitude is 1/5, and now we're going to graph our sine or our cosine graph of x. So cosine is 0. We're going to put in here 1/5, 2/5, 3/5, 4/5, 1, and then negative 1/5. Then we're going to go down to a negative 1. So cosine of 0 is, cosines are maximum minimum starter. So if it's a cosine, it starts at a maximum. Then at pi halves, it's at 0. By the time we get to pi, we're at a negative 1. 3 pi halves, 0. 2 pi, we're back to once around the circle, 1. And then we've got a repeat of what was happening prior because it's periodic. So here's what it looks like, our parent function for cosine curve through a period of 2 pi. Okay, so then the next thing we're going to do is we're going to take all those values and multiply them by negative 1/5. So remember, your zeros are going to be stuck. They can't move, so I can go ahead and put those on. But what's going to change is the 1 value is going to get multiplied by negative 1/5. So we see the reflection and the shrink happen at the same time. So if it was a true just reflection, it would reflect it down here to a negative 1, and then the 1/5 is the shrink, so it brings it back to here. So all these values are going to get shrunk down to 1/5 the original size. So if we take a negative 1 times a negative 1/5, it reflects about the x-axis, and it makes it a positive 1/5. The negative 1, or the positive 1 becomes a negative 1/5, and vice versa on these others. They keep flipping over the x-axis. So then our graph would be like this. And like I've kind of said it a couple times, I don't know if you caught on, but anytime you do a cosine curves are max or min starters. So when I see this one, if I see a positive cosine, I know it's going to be a maximum starter. If I see a negative, then I know it's going to be a minimum starter. When I say starter, we're starting on the y-axis. Where is it starting on the y-axis? At its maximum value or at its minimum value? Anytime we have a negative leading coefficient, it will be a minimum starter. If it's a positive, it'll be a maximum starter. So there's an example of reflection across the x-axis. Now we'll look at a sine curve. So the sine curves are centerline starters, and the sines are always harvesting the y value, so you got to think of your unit circle. And let's go ahead and take care of this preliminary work. The amplitude of this function is the absolute value of the negative 4, which is just 4. So the amplitude of this is 4. Sines are centerline starters, and the sine of a 0 radian is 0. That's its coordinate of the y. And at pi halves, it hits its maximum value of 1 at pi halves. At pi, it's at 0. 3 pi halves, it's at negative 1. 2 pi is at 1. Then it repeats the values. Maximum, 0, minimum, back to maximum. Here's what the curve looks like through 2 pi at 2 revolutions. Now we're going to do an amplitude of 4, and this is a negative 4, so it's supposed to reflect all these points that are high are going to come down. So if it was just a true reflection, these points here would come down, this point would come up, this point would come down, this point would go up. and your zeros are not going to be changed. So these zeros are going to stay in positions. No matter what you do, when you multiply times 0, it stays 0. But the other thing we're going to do is we're going to magnify, or we're going to stretch these by an amplitude of 4. So rather than being here, it's going to stretch it down to a negative 4. Instead of being at a positive 1, it's going to be a positive 4, not 5. And then down to a negative 4. Then up to a positive 4. And then down to a negative 4. So, sine curve. We got the negative, so it's a reflection across the x-axis. And we have the amplitude change. So we get our entire graph that looks like this. You should see a reflection of the red graph and blue graphs are reflections, but we also have this vertical stretch pulling the maximum minimums down to a positive 4 and negative 4. So a pretty simple variation and a pretty simple transformation of your original sine and cosine graphs.